Sampling. Learning objectives. At the end of the session, the learner/S will be able to define important terms such as sampling, sampling frame, sampling interval, stratum, and cluster. Differentiate the following sampling-related terms: population and sample, target and sampling population, and elementary and sampling unit/S. Discuss different sampling designs, and enumerate possible biases in sampling. Defining sampling, and its related terminologies. Sampling. Deriving a sample, a subset or segment of a population. Results from the sample are used to infer or generalize about the target population. Has two important key features. 1. Representative, and 2. Minimum number of observations. Alt. Has the following advantages: lower cost, shorter time, better quality of data. Requires only a smaller number of data collector who can be trained more rigidly and supervised closely. Allows the use of more complicated and accurate technical methods, which are often expensive and time-consuming. Detailed questions on some topic requires time. Only possible approach for some studies. Population. Refers to the entire group of individuals or items. Has two types relevant to sampling. Target population. Group from which representative data is desired, and inferences are made. Sampling population. Population from which a sample will actually be taken. Example. A municipal health officer is trying to determine the prevalence of malnutrition among children between 6 and 12-year-olds in San Juan. The MO conducted a survey among school children aged 6 to 12 years attending local elementary schools. Suggested answers. Target population: 6 to 12-year-old children in San Juan. Sampling population: 6 to 12-year-old children in San Juan. Issue/S with sampling. Bias: possible non-inclusion of out-of-school children. Sampling unit. Units which are chosen in selecting the sample. May be made of non-overlapping collection of elements or elementary units. Elementary unit. Also called element. Object/person from which observation or measurement is taken. Sampling frame. Tool or list containing the collection of all sampling units. Its coverage determines if a gap between the target and sampling population exists. Sampling error. The variability in the estimates derived from various samples from the same population. Example. A municipal health officer is trying to determine the prevalence of malnutrition among children between 6 and 12-year-olds in San Juan. The MO conducted a survey among school children aged 6 to 12 years attending local elementary schools. Suggested answers. Sampling frame. List of enrollees in the local elementary schools. Sampling unit. School. Elementary unit. Children aged 6 to 12 years. Finite population. Where the population of all individuals or elements that are finite or countable. In contrast with an infinite population. Homogeneous population. One where elementary units are alike or have similar characteristics. In contrast with a heterogeneous population. Determinants of sample size. Parameter to be estimated. The proportion and the mean are examples of parameters that one would estimate from a sample population. Precision of the estimate. The degree of closeness of an estimate to the unknown parameter. Level of confidence of the result. As the level of confidence decreases, the size of the sample decreases. Nature of the research. Measuring a proportion or a mean. Determining the significant difference between two proportions or two means. Sampling design. Criteria for good sampling designs. Representative of the population. Adequate sample size. Practical and feasible, and economy and efficiency of the design. Is a definite plan for obtaining a sample from a given population. Refers to the specific technique or procedure adopted by the researcher in selecting the elements for the sample. One must prepare a sampling design which is reliable and appropriate for the planned research study. Conditions to consider in developing a sampling design. Type of population. Sampling unit. Source list or sampling frame. Size of the sample. Parameter/S of interest. Statistic, numerical characteristic of a sample. Parameter, numerical characteristic of a population. Budgetary constraint/S. Types of sampling design include random or probability sampling methods. Elementary units have a known, non-zero chance of being selected. A sampling frame is the basis for the selection process in the sample. Non-random or non-probability sampling methods. The probability of element of a population to be chosen is difficult to determine or cannot be specified. Best sampling design utilized for descriptive purposes. Non-probability sampling designs. Convenience sampling. Also called accidental or haphazard sampling. Based on the availability of participants. Subjects selected are those who are easily accessible and/or available to the researcher. Useful results can be obtained. Examples include: interview the first 50 patients who consulted in the clinic. Recruit the ER nurses available at the time of data collection for a survey. Quota sampling. Samples of a fixed size, quota, are obtained based on a pre-specified criteria. Elements are sampled from each group based on a characteristic, example age, sex, religion, etc., at the researcher's discretion. Examples include: visiting a rural health unit to interview 50 women and 50 men who had just received their second booster dose for COVID-19. A student collects at least 30 fecal samples in a specified street in Manila to screen for helminthiasis. Purposive sampling. Also called judgment sampling. One may implicitly choose a representative sample based on experts' subjective opinion or on a pre-specified criteria. Usually done in qualitative study designs. Examples include: a researcher selects 3 or 4 households from a municipality based on their proximity to the central office and perceived representativeness on certain issues related to the community. Selecting study sites based on the level of cooperation of the residents. Respect to authority and/or expert opinion. Snowball sampling. Used when selecting participants with very specific characteristics, example hard-to-reach groups or hidden populations. Effective when a sampling frame is difficult to identify or when variable of interest is associated with a negative stigma. Recruitment depends on the referrals of those participants included earlier. Sampling is not representative but is quite useful. An example would be: recruitment of IVDU. First respondent identifies and invites another person he knows is also an IVDU, and so on. ASCII. Alt. Advantages. Easier to execute. Used when it is the only possible means. Disadvantages. More likely to produce biased results. No defined rules to compute for estimates. Cannot compute the reliability of the estimates. Probability sampling designs. Major techniques. Simple random sampling. Simplest and most basic sampling design, written as SRS. A method of selecting n units out of n population units giving each element equal probability of being chosen. Can be implemented using the following. Sampling frame a requirement. Random number tables published or computer generated. Selection of the sample. An advantage is the simplicity of its design and analysis. Some of the disadvantages include: requires and relies heavily on a sampling frame. Not cost efficient. Not reliable for more complex procedures, i.e., small area estimation. Example: draw a random sample of 8 cities, n equals 8, in the national capital region. Suppose we will study the health facilities of these cities to describe their continuing responses to the pandemic. ASCII. Alt. Suggested answers. Sampling frame. List of cities in the national capital region. Method of selection. Selection of the sample was carried out using lottery by rolling 17 identical pieces of paper, numbered from 1 to 17. Selection of the sample. Subsequently, 8 pieces of paper were randomly selected numbered 15, 7, 1, 16, 9, 5, 2, and 6. Enumerate the cities in NCR included in the sample. If we use a table of random numbers. Method of selection. Select a random point in the table by dropping your index finger vertically on the page and noting the row and column where your finger landed. Depending on the number of the entire population, the digits will be the random start. Record the next numbers appearing downward depending on the sample size. ASCII. Alt. ASCII. Alt. If we use a table of random numbers. Selection of the sample. Since we picked the numbers 13,01,07,03, 11,06,04, and 05. The sample includes Pateros, Caloocan, Marikina, Makati, Pasay, Manila, Malaban, and Mandaluyong. Stratified sampling. Expressed as SYS. A method of selecting n units out of n subpopulations can be implemented using the following. The population is partitioned into non-overlapping groups called strata. SRS or SYS is then performed separately within each stratum. Alt. The stratifying variable should be mutually exclusive, non-overlapping. Population, elements, should be homogeneous within stratum. Population, elements, should be heterogeneous between the strata. Most frequently used strata are residence, urban vs rural. Sex, male vs female. Age group. Allocation of samples to strata. Equal allocation. Proportionate allocation, proportional to stratum size. Optimal allocation. Cost-based sample allocation. How to do stratified sampling. 1. Divide the population into non-overlapping groups. 2. Determine the distribution of the sample and the population. 3. Choose a method of allocation for the strata and the sample. 4. Draw elements using a random sampling procedure for every stratum. Visual of simple random sampling, selection of 6 out of 18 people, visual of simple random sampling, selection of 3 out of 9 men and 3 out of 9 women. ASCII. Alt. Its notable advantages include more representative subgroups, more precise estimates, lower sampling error. Data collection can be organized using the strata. Some of its disadvantages include a sampling frame is needed for each stratum. Sample size in a stratum may be low. Data analysis method is complex. Sample size estimation is difficult in practice. Systematic sampling. A variation of SRS, written as SYS. A method of sampling every k unit sample from regular or arranged units within the n population size to the sample size n. K equals n/n. Can be implemented using the following. Random selection of a number from 1 to k, which will be the starting point in the selection of element. Then, select every kth unit after the starting element. How to do SYS. 1. Compute the sampling interval, from a population size, n, of 80 households, and a sample size, n, of 10. The sampling interval, k, is 80/10 equals 8. 2. Draw a number between 1 and k, this is the starting point, r. 3. The fifth household is part of the sample, so the next sample would be r plus k equals 5 plus 8 equals 13th hh, then. 4. Third observation, r plus 2, k, equals 5 plus 2, 8, equals 21st hh. 5. Fourth observation, r plus 3, k, equals 5 plus 3, 8, equals 29th hh. 6. Nth observation last, r plus, n1, k equals 5 plus, 9, 8, equals 77th hh. How to do SYS. If the sample is not an exact multiple of the n. 1. Consider, n equals 175 and n 1000. So, k 1000/175 equals 5.71. 2. Draw a number between 1 and k, this is the starting point. 3. If k equals 5, then n equals 1000/5-200. Stop the selection of samples when n equals 175 achieved. 4. If k 6, then n equals 1000/6 equals 166.67 Treat the sampling frame as a circular list and continue the selection of samples from the beginning of the list after exhausting the list during the first cycle. Allows the random start RTO start between 1 to n, 1 Rn. Its advantages include provides a better random distribution than SRS. Simple to implement. May be started even without a complete listing frame. With an ordered list, the variance may be smaller than SRS. Some of its disadvantages include requires a close approximation of a population. Fractional chance of selection. Periodicity. Cluster sampling. Method where each sampling unit is a collection or cluster of elements rather than a single element of the population. The total population is divided into small subdivisions, cluster, and some clusters are randomly selected for inclusion in the overall sample. Usually conducted for cost efficiency. Clusters group of population elements, constitutes the sampling unit. Primary sampling unit the clusters. Secondary sampling unit households or individual elements. How to do cluster sampling. 1. Prepare a sampling frame made up of groups or clusters of the elementary unit. 2. Randomly select the clusters using a specific sampling procedure, example SRS, SYS, STS, etc. 3. All the elements in the selected clusters are then included in the sample. If the cluster is a household, then a random sample of households will be selected and all the children in the randomly selected households will be included in the sample. An advantage is the simplicity of its design. Some of the disadvantages include: may not reflect the diversity of the community since other elements in the same cluster may share two similar characteristics. Provides less information per observation than an SRS of them name size. Standard errors of the estimates are high, compared to other sampling designs with same sample size. Example: a survey was done in San Jose Elementary School aimed at determining the prevalence of obesity among school-age children. The researcher requested the list of classes, sections, after which he randomly selected the classes, and all students from those selected classes were included in the study. Identify the following: target population, sampling population, sampling frame, sampling unit, elementary unit, sampling design. ASCII. Alt. Multi-stage sampling. Carried out in stages or phases. Involves more than one sampling method. Involves more than one sampling unit. 1. Primary sampling unit, PSU. 2. Secondary sampling unit, SU. 3. Tertiary sampling unit, TSU. 4. The process can continue as before up to the last sampling unit. Examples of multi-stage sampling? If we plan for a two-stage simple random cluster sampling. 1. List all the clusters in the population. 2. First stage, select the collection of clusters. Using the previous example of selecting schools for inclusion, we use simple random sampling. 3. Second stage, select the clusters. Clusters are selected from the schools using simple random sampling. 4. All units within the chosen clusters will be included. A nationwide survey to assess the prevalence of adolescent exposure to cigarette smoking and alcohol drinking was planned. The researchers will choose 2 provinces out of the 17 regions in the Philippines, followed by selecting 3 towns for every chosen province. 2 urban and 2 rural barangays per chosen town will be included, and 36 households per barangay will be selected using a spot map. Every 5th household from the national road of the chosen barangay will be selected, and all household members are included in the survey. Selection process. Sampling. 1. Nationwide survey. 1. Stratified via regions. 2. 2 provinces per region. 2. PSU, SRS. 3. 3 towns per province. 3. SU, SRS. 4. 2 urban and 2 rural barangays per chosen town. 4. TSS, SIRS. 536 households selected per barangay. 5 4th level SU, SYS. 6. Interview all household members. 6. HH is a cluster of elementary units. Design, 4-stage stratified, systematic, cluster random sampling design. Known advantages include: cost-efficient design. Sampling frame of elementary units not required. Samples are easier to collect. Some of the disadvantages include: more complicated analysis. May need a bigger sample to improve precision of estimates. Sampling procedure non-probability sampling, convenience, judgment/purposive, quota, snowball, or probability sampling, simple random, systematic, stratified, cluster, then multistage sampling.